So we're given several thermochemical reactions, and we have the reaction and the delta H for them. And we're trying to calculate the standard heat of formation of this strontium carbonate. Now, what does that mean? The heat of formation of a reaction is the energy change to produce 1 mole, or the enthalpy change to produce 1 mole of this substance from the elements in their most stable form. So Sr is a solid, that's a metal, it's a solid, that's its most stable form. Carbon's most stable form is graphite, and oxygen's most stable form is O2. Now we need to balance it for 1 mole, so we have to keep a 1 on this side because that's the definition of heat of formation. So we are going to put, let's see, 3/2 here to give me 3 oxygens. We have 1 carbon, 1 strontium already. So what we're trying to do is determine the delta H of this reaction. The delta H of this reaction would then be, by definition, the heat of formation. So let's try to construct this reaction from these puzzle pieces. We need strontium on the left-hand side of the equation, 1 mole of it. We look up here, and the only equation that has strontium is this first one. But it's 2 moles on the right-hand side. So we have to reverse the reaction and divide by 2. So we will reverse the reaction and divide by 2. Okay? If we do that, we can determine the delta H of this reaction by changing the sign, because we reversed the reaction, and dividing it by 2, because we cut it in half. All right, so that gets our strontium in place. Now we're ready to get our carbon in place. So here's the graphite equation, this third equation here. It's got 1 mole of graphite on the left-hand side. That's what we needed, so we'll use it exactly as we see it. Carbon, graphite, plus O2 gas, producing carbon dioxide gas. Since we used it just as we saw it, we'll take the delta H just as it comes off the table there, 394 kilojoules. So then I got the graphite in place. The O2, so far we've got 1.5 moles of O2. Okay, so it looks like it's good. Now let's make sure we get the SrCO3 in place. Okay, so we look up here, and SrCO3 comes from this second equation. It has 1 mole on the right-hand side, so we're going to use it just as we see it. SrO solid plus CO2 gas producing SrCO3. Since it's just SrCO3. And that's not a gas, it's a solid. Okay, so the delta H of this reaction, I read it right off of here, is a negative 200. Boy, I'm having a hard time writing. 234 kilojoules. Now let's verify that all of these do add up to give me the reaction I'm looking for. I'm trying to obtain this reaction. So we've got the strontium, we've got 1.5 moles of oxygen, we have SrO canceling with SrO, we've got carbon dioxide canceling with carbon dioxide, and that leaves me with exactly what we see up here: 1 strontium, 1 carbon, and a total of 1.5 oxygens, 3/2 oxygens, and the SrCO3. So yes, that does construct this reaction. So these have to add up to give me the delta H of the reaction. When you add all of these up, you will get a negative 1220 kilojoules. So that is the delta H of this reaction, and by definition, that would be the calculating the standard heat of formation of the strontium carbonate.